Today, I want to talk to you about how Autonomous Database simplifies your database management so that you can focus on helping your users and customers rather than managing your databases. I want to walk you through a brief overview of Autonomous Database and then talk to you about how it automates the management, reliability, and security of the database for you. So Autonomous Database is a family of database cloud services, a fully managed database cloud services that Oracle provides. There's different workload types, different Autonomous Database types, I may say, you may choose depending on your workload requirements. There is ADW, Autonomous Data Warehouse, which is targeted for running data warehouse and analytical workloads. There's ATP, Autonomous Transaction Processing, which is used for running OLTP and transactional workloads. There's AJD, Autonomous JSON Database, which is targeted for document store apps and JSON workloads. And there is the Apex service, which is a low-code database, low-code development environment, which you can use to build web applications using Oracle Apex. There's multiple deployment choices or models for running Oracle Autonomous Database. The first one is running it in Oracle's public cloud. And in here, you have two deployment options, one of them being Autonomous Database on shared infrastructure, and the second one being Oracle Autonomous Database on dedicated infrastructure. You may even choose to run Autonomous Database on your own on-prem data center. It's available on Exadata Cloud at customer environments to run on your on-prem data centers. Oracle Cloud also provides dedicated regions, which are dedicated regions to specific customers, which you can use to run Autonomous Database, as well as any other Oracle Cloud service. Let's start talking about how Autonomous Database simplifies things. The full lifecycle management of the database is automated in the Autonomous Database. This starts with provisioning of new databases. It's quick and easy to provision new databases. All databases provisioned under Autonomous Database are created on highly available scale-out infrastructures without you as the user doing any config or setup. It secures all databases out of the box. It protects them against internal and external threats. It applies security patches online. It encrypts all data. It encrypts all network communication between the client and the server. It manages all maintenance operations. Things like backup and recovery and patching are completely automated, and you can control these things using UIs and APIs. It protects against software and hardware failures. As I mentioned, all the database run on highly available, redundant, clustered infrastructure. It can even file bugs for the issues it sees so that these bugs are fixed in the next patching cycle or next maintenance window. It uses a scale-out elastic architecture, which you can use to manually or automatically scale anytime you want. And all scaling is done automatically and in an online manner without any downtime. And you pay only for the amount of resources you use. It optimizes each database based on the workload type that is running on the database. It decides on things like data compression, parallelism settings. It provides out-of-the-box automated workload management functionality that I'm going to be showing you in a couple of slides later. So let's start with daily management operations that all admins do for their databases. Autonomous Database automates end-to-end management of the database. It automates things like provisioning, backup and recovery, patching and upgrades, cloning, and more. All of these things can be controlled by the user using the Cloud Console UI or APIs. You can also use things like SDKs and command line tools to control these operations. Autonomous Database is tightly integrated with other cloud services. A couple of examples include Oracle Events and Notifications. You can subscribe to specific events and receive email and other types of notifications about things happening in your database. You may use OCI monitoring metrics to look at the performance of your Autonomous Database. Autonomous Database is integrated with object stores. This not only includes Oracle's object store, it also includes Google, Azure, AWS, and any other S3 compatible object store. It allows you to run queries on top of files sitting on these object stores, or it allows you to load data from files sitting in these object stores. An interesting example I wanted to point out here is PL SQL SDKs. These SDKs are provided out of the box in each autonomous database, and they allow you to call other Oracle Cloud services. A typical example is this allows you to call an Oracle function running in the Oracle function service to do some external processing outside of your database. If we start with provisioning, it's really quick and easy. You use the UI or API to provision databases. You pick the workload type that you want to run on this database. You pick the deployment type, whether it's shared infrastructure or dedicated infrastructure. And then you provide the number of CPUs and storage that you want to use. You can start as small as 1 OCPU and 1 terabyte of storage, and you can increment these things or scale up these things anytime you want, automatically or manually. As you see on the screenshot here, you may also choose to run a free database. This gives you a free database in Oracle's Always Free tier, which is free for life, and you can use it to do any dev, test, or prod type of use case you want on this database. Again, without paying for it, because it's in the Always Free tier. After provisioning the database, backup and recovery is automated. You don't need to do any backups at all. Autonomous database does backups every day, and during the day it backs up the archive logs periodically. We provide a 60-day retention period for backups. That means you can restore or recover your database in place or out of place to any point in time during these 60 days. And backup and recovery and the storage required to store these backups is provided free of charge in Autonomous Database. As you see on the UI screenshot here, we also allow you to do manual backups to your own object store. You can choose to do this operation, but that's completely optional. If you don't do any manual backups, you're not losing any backup and restore functionality. You can restore to any point in time in this 60-day retention period. Patching is completely automated in the Autonomous Database. All patches are applied online during specific maintenance windows without any database downtime. These maintenance windows are announced on the UI, as you see on the screenshot here. So by looking at the UI, you exactly know when the next patching cycle or maintenance window is going to be for your database. At this point in time, we are providing fixed maintenance windows, but we are working on a feature to enable flexible maintenance windows. When that is generally available, you'll be able to pick and choose your maintenance window from available scheduled windows. I mentioned there's no database downtime during patching because all the patches are applied in a rolling manner in a clustered environment. Your applications may see brief disconnections, but they may immediately reconnect and continue running because the database is always up and running. To prevent even these disconnects for your apps, you may enable features like application continuity and transparent application continuity, which are features to allow your apps to continue even without disconnecting, without losing any transactions, or without losing any work. If you want to upgrade your database to a newer version, that is again automated and available with one click. Whenever a new database version is available on the Autonomous Database, you will see on the UI an upgrade button for the next version. When you click on it, the database is going to be automatically upgraded, and there's minimal downtime for running these upgrades. The last time we did these upgrades was from 18C to 19C, and across the board for all customers, we saw database downtimes of less than 10 minutes for these upgrade operations. I said Autonomous Database provides automated workload management out of the box. How we do this is each Autonomous Database comes out with predefined consumer groups or database services, and these services have different concurrency and parallelism settings assigned to them. all autonomous databases have the same services. And the users and apps can choose which service to use at connect time. So your users may, at connect time, choose to connect with Hive, for example. I have a table here that shows an example from an ADW database. It comes out with 3 services called high, medium, low. And as you see on the table here, it provides different concurrency levels out of the box. For example, if you have users connecting with high, they will be able to run 3 concurrent queries. If the 4th and 5th query are coming, they will be waiting in the queue until one of the earlier queries finish. You may mix and match these services, of course, at connect time. You may have some users connecting with low, some users connecting with medium, based on their parallelism and concurrency requirements. If you're not happy with these out-of-the-box settings, we have PL SQL APIs and UIs so that you can change these settings depending on your performance requirements. Some tools, like the SQL web worksheet we have under database actions, provide these service options at their UI. On the right here on the screenshot, you're seeing the web SQL worksheet, which allows you, using a drop-down, to select which service to use to run your queries with. You may use cloning in Autonomous Database for different purposes, like creating development and test environments, QA environments from your production systems, or creating sandboxes for your data scientists so that they can work with their own copy of the source database. We provide a couple of different clone types that are listed in the slide. You can have full clones, which are exact one-to-one copies of the source database with their schemas and data in them. You may have metadata clones, which are schema-only copies, which you can give to your users, and they can upload or load their data into these schemas themselves. You can do clone from backups or point-in-time clones. With the 60-day retention period, you can create a new database from any existing backup, any point in time during these 60 days. So you can do things like clone a database that has my data as of 2 days ago by using this clone from backup functionality. And lastly, we have refreshable clones, which are read-only copies of the source database, which can be refreshed with new data from the source database with the click of a button. I want to show you a brief, an example use case for refreshable clones. In this use case, I have an operational reporting database that is continuously loaded and fed from source systems. And I have 2 refreshable clones, read-only copies of my source database that are given to sales and finance departments. In this case, even if the loads are continuously running an operational reporting database, sales and finance departments are able to work with their own data without seeing new data from the source system, which is the operational reporting environment. There are 2 benefits of this approach. The first one is workload isolation. Since operational reporting is completely independent of sales and finance, the loads running in the operational reporting environment don't impact the sales and finance users, and they can keep running their own reports independent of the operational reporting system. The second one is billing or cross-charging. IT departments can charge the sales and finance department, in this case, based on the resources they're using, because they're working on an independent copy of the database with their independent compute resources. At this point in time, these refreshable clones are read-only copies of the source that can be refreshed, again, using the UI. We're working on making these refreshable clones read-write, which means if the sales department wants to do some updates, wants to create some tables for their own purposes, they'll be able to do that. After their analysis is done, they'll be able to say, I want to make this clone refreshable again and refresh it from my source databases again. So they'll be able to reconnect the clone to the source and update it with fresh data from the source system. The next thing I want to mention here is scaling. Before I talk about auto scaling and how we provide it, I want to talk to you a couple of sizing or budgeting options or methods that is used by companies and customers. The first one is static sizing or budgeting, in which case you're sizing your server resources or compute resources based on peak workloads that you have. So if you have an end of day workload, which requires a lot of CPUs, you provide a server or compute based on that many number of CPUs. This also means, obviously, except those peak periods of workloads, you're wasting those resources because you're not using them because they're staying idle. You may even be paying license fees on those idle resources during non-peak times. The second one is static sizing or scaling, in which case you start with a server type or node shape, which has some number of CPUs and some storage capacity assigned to it. If that's not enough for your workload, you add more servers of the same type, which means you can double or triple or maybe more your compute and storage capacity, but it's all based on fixed shapes. So it doubles and triples and more. The third one is open-ended, which means there's no limits on the amount of resources that the system can use. As long as there's incoming requests or workloads or queries, the system keeps scaling up and up. This is, of course, really hard to budget and estimate for. Autonomous Database uses a different approach here. All databases, as I mentioned, are running on elastic scale-out infrastructure. At any point in time, users can manually scale up and down these resources, or they can enable auto-scaling, which is going to scale the system based on incoming workloads. You pay only for the resources you're using here. If you decided to auto-scale systems, if the system used 3 CPUs, you're paying for 3. If the system used 4 CPUs, you're using for 4. You're paying for exactly what you're using. You can turn off or stop databases at any point in time you want. That means you stop paying for those databases during that time. This is used commonly by some of our customers for dev and test purposes. They stop or turn off their dev test systems during the weekend, which means they're not paying for any compute resources during that time. And on the Monday morning, they come back and start up their databases. At this point in time, these operations are done manually, these stop and start operations. But pretty soon we'll be releasing a scheduled or auto stop and start functionality, which customers can declare when they want to stop and start their databases without manually initiating these operations. So I talked about manual and auto-scaling. Auto-scaling is a setting in the Autonomous Database. So I mentioned about manual and auto-scaling before. Auto-scaling is a setting in the Autonomous Database, which you can enable and disable at any time you want. When enabled, auto-scaling allows the database to use up to 3x more CPU and I/O resources when there's an incoming workload that requires those resources. Just like manual scaling, auto-scaling is completely online with no database or application downtime. If auto-scaling is used because you have an incoming workload, Autonomous Database charges for only the number of CPUs you used during that workload, which brings you a true pay-per-use type of charging and billing. If the workload goes away and you're not using that many number of CPUs anymore, you stop paying for that many number of CPUs. So it's kind of much more dynamic than any other options that I mentioned before. I want to show you an example to compare what happens with or without auto-scaling and to show you the benefits of auto-scaling. In this example, I have a 4.0 CPU database. 4.0 CPU means 8 threads, 8 vCPUs, which can run 8 sessions on the CPU. So I'm running the exact same workload on a database without auto-scaling and with auto-scaling. On the left, you see the database without auto-scaling. On the right, you're seeing the database with auto-scaling. In both of these cases, I started with 8 sessions, which can use 8 vCPUs. And then I added 16 more sessions that ask for CPU. As you see on the spike here on the left, if you look at the gray area, it shows that 16 sessions are waiting on CPU. And the green area shows 8 sessions are actually running on CPU. In total, I have 24 queries running, but 16 of them are not able to use the CPU because this is a 4.0 CPU, 8 vCPU database, and I didn't enable auto-scaling. So I'm paying for 4.0 CPUs in this case, but my users, some of my users are waiting for CPU. On the right, I have the same workload running with auto-scaling. Again, I started with 8 sessions and then I increased to 24 sessions. Compared to the graph on the left, you don't see any gray area on the right graph. All 24 sessions are able to consume CPU and they're able to proceed without waiting for any CPU resources. So as the graph shows, if you compare the same workload with or without auto-scaling, you can see that for this workload, auto-scaling will allow me to get 3x more throughput just by enabling it. Let's say this workload ran for 2 hours. I'm only paying for these additional CPUs for 2 hours. When the workload goes away, I go back to paying for 4 CPUs again, because we're back to the base CPUs that I provisioned using the UI. So let's talk about a couple of reliability things that we automate for you in the Autonomous Database. All autonomous databases run on highly available self-healing infrastructure with redundant hardware components that is able to recover from failures. So any server or storage failure is recovered by the database itself. And for any issues that is seen in the system, as I mentioned before, Autonomous Database automatically files bugs so that our development organization can fix these things for you without you even filing bugs and SRs, so that these bugs are fixed in the next maintenance cycle or maintenance window. This is protection against hardware and software failures in the same region or data center. For protection against data center failures, we provide disaster recovery functionality, which provide standby database that are exact copies of the primary database. This protects you against data center failures and disasters. There is cross availability domain and cross region standby options that are available. So for disaster recovery purposes, we recommend customers to use Autonomous Data Guard, which is a simple and transparent data protection functionality. You can enable or disable this with the click of a button. Once enabled, this will create a standby database for you, and this standby database will be replicated continuously with changes from the primary database. This is completely transparent to user apps or users connecting. When a failure occurs and your database switches to the standby database, you can use the same connection strings and your app can just reconnect and continue working on the standby database. We have 2 types of standby databases. The first one is cross-AD, which is inside the same region, but across availability domains. This gives you an RPO of 5 minutes and RTO of 2 minutes. And then we have cross-region standbys, which gives you RPO of 5 minutes and RTO of 1 hour. As you see on the screenshot here, you just click a button that says enable Autonomous Data Guard, and you pick the local region or remote region that you want to place your standby in. After your standby database is created, you may want to switch over to it for testing purposes, or you may want to fail over to it in case of some disaster happens. These are available with the click of a button. For cross-AD standbys, we automate the failover as long as we can guarantee 0 data loss. In other cases, you may need to click a button for doing the failover or switchover operation or initiating this operation yourself. As you see on the UI here, it's just 1 click. You confirm it, it does the switchover and failover for you. So the last thing I want to mention and talk about today is the security features and automation that we have in the database. I want to talk to you here about 2 things. The first one is the database security and infrastructure security that Autonomous Database provides. Autonomous Database encrypts all data that is uploaded or loaded into the system. So there's no unencrypted data in any Autonomous Database. Not only data, we also encrypt all network communication. So any network traffic between your clients and the database is completely encrypted using SSL. We provide native auditing functionality in the Oracle database. So if you know Oracle auditing and if you know how to enable different audits, you can do these things. We enable specific audits out of the box. So there's a couple of audit options that are already enabled for you. You can choose to look at the views and see that those audit records. But of course, you can add additional audits on users, tables, specific SQL commands, and more. You can do all kinds of network security add-ons on top of it, like using private IP addresses, using security lists and network security groups on the OCI network level. So Autonomous Database supports all of those. If you want to restrict your users coming in from the database, you can do so. You can define things like access control list, which is an allow list of IP addresses. So you can specify exactly which clients are allowed to connect to your database. In addition to all these database and network functionality we have, Oracle Cloud also provides a cloud service called DataSafe, which is a one-stop shop for managing security across multiple databases. These may be autonomous databases, as well as other Oracle Cloud databases that you may have. So let me briefly talk about DataSafe. Oracle DataSafe is a cloud service on its own. This is free for all autonomous databases, as well as other Oracle Cloud databases. Again, this allows you to control security for a single database or multiple databases using a single UI. It allows you to do things like security assessment for your database and users. It warns you about things like users with weak passwords, users with passwords that are about to expire, users with a lot of admin privileges that they shouldn't have. So it looks at tens, hundreds of settings in the database and provides you UI reports on the UI, as you see on this screenshot here. It also allows you to do sensitive data discovery. So you may ask DataSafe to look at your databases and figure out if you have any sensitive data. These include things like addresses, personal information, credit card information, and it reports you on those things again on a graphical user interface. It allows you to do data masking on your autonomous databases. If you clone your database from production and you want to give it to a developer or a QA person, for example, you may ask DataSafe to mask the data before you hand out the database to your developers or QA people. Again, this is free with all Oracle Cloud databases, including Autonomous Database. That's why we recommend people to always enable this. Enabling DataSafe for an autonomous database is one-click operation. You go to your Autonomous Database console and say, register this database with DataSafe, and that's it. I talked about Autonomous Database encrypting all traffic and all data in the database. With respect to data encryption, we provide two options for managing encryption keys for this data encryption. The first one is the default, which is Oracle Managed Keys, in which case Oracle manages keys for you, rotates the keys for you. You don't have to do any key management at all. The second one is Customer Managed Keys. So as a user or customer, you may choose to use your own key to do data encryption on Autonomous Database. To support Customer Managed Keys, Autonomous Database is integrated with the OCI Vault service, which is the key management service in the Oracle Cloud. OCI Vault service allows you to create new keys or bring or import your own keys. You may choose any of these for Autonomous Database as well. And then after you create the key or import your key, you can come to the Autonomous Database and say, use this key for encrypting my data in my database. Rotation of these encryption keys, in this case, is completely controlled by you. You can at any point in time come to the console and rotate the key or switch to a completely new key that is sitting in OCI Vault. So as a summary, I wanted to cover a couple of areas about management, reliability, and security automation in the Autonomous Database. Of course, in 30 minutes, I was able to cover only a few of these. There's a lot more. If you want to learn about these features and more, we have an Autonomous Database blog that you can watch and read. We talk about features and use cases in this blog. We have a hands-on lab that you can use to create an Autonomous Database and play with it. You can access it using the URLs here. And obviously, there is a lot of official documentation about each of the features that I described today. If you want to try Autonomous Database yourself, or Oracle Cloud provides an always free tier which is going to give you 2 autonomous databases for free, each one with 1 OCPU and 20 gig of storage. You can use these to learn about the autonomous database, or you can use 30-day free trial credits. And these credits are, you can use these credits against autonomous database as well as any other Oracle Cloud service that you want to try in Oracle's cloud. So if you go to this URL that is on the screen, oracle.com/database world free tier, you'll be seeing more information about these options. So thank you for joining the session. If you have any comments, questions, I'll be happy to have a conversation. You can reach out to me using the Twitter handle here. I'll be happy to respond to your comments and questions. Thank you.